friends. In this video, we will study that what is an alternating current bridge. We will see that where these bridges are used and what are the components or what is the basic alternating current bridge network is like. So let us start with our topic. The alternating current bridges or the AC bridges, they are the most popular, convenient and the prominent or accurate instruments which are used for the measurement of AC resistance, capacitance and inductance. These bridges are just like the DC bridges, but the difference between the alternating current bridges and the direct current bridges is the power supply. In the DC bridges, the power supply provides us a DC current, whereas the AC bridges, in the case of AC bridges, the power supply is an alternating current power supply. Okay, so just there is the difference of the power supply in the DC and the AC bridges. The AC bridges, they not only measures the resistance, capacitance and inductance, or we can say not only the electrical parameters, but they are also used for the measurement of storage factor and the power factor. Now, all the alternating current bridges, they are based on the Wheatstone bridge. The Wheatstone bridge is the most simple and the basic bridge network. The Wheatstone bridge, it is a DC bridge in which we are using the battery or as the EMF as the power supply in the bridge network. So all the alternating current bridges in their construction, they are based on the Wheatstone bridge. So just like the Wheatstone bridge, it is having 4 arms, and in the 4 arms we have the 4 resistances connected, and in between that we have a galvanometer which measures the null deflection, okay, and which is used for balancing the bridge. So here also in the AC bridges we will have the 4 arms. Instead of 4 resistances, here we will have the 4 impedances. One of the impedances will be unknown and all the other resistances or impedances, they will be known to us. Now, instead of the galvanometer in the Wheatstone bridge, in the AC bridges we will have a detector. And in place of the battery which is providing the power supply to the bridge, here we will have an AC voltage power supply. So the difference between the Wheatstone bridge and an alternating current bridge is that in Wheatstone bridge we have 4 resistances. In alternating current bridges we will have the 4 impedances. Impedances are the combination of the resistance, capacitance and the inductance. Okay, and instead of the galvanometer, here we are having a detector, and in place of the battery, here we are having an AC voltage source. So if we draw a basic AC bridge network, it will be like So, four arms having four impedances Z1, Z2, Z3 and Z4. In place of galvanometer, in between the arm B and D, we have the detector, and in between arm A and C, we are having the AC voltage source. This is the symbol for representing an alternating current. Okay, so here we are having an AC voltage source which is providing the power supply to the bridge network. Okay. Now, other than the measurement of these electrical parameters, the AC bridge networks, they are also used for the phase shifting purpose. Now, in the AC bridge networks, as I have told that it consists of an AC voltage source and a detector is also there, and this detector is used for balancing the bridge. So let us study the sources and detectors, the various types of sources and detectors present in the alternating current bridges. Now, when the alternating current bridges or the AC bridges, they are used for the measurement at low frequencies, then at low frequency the power line, it can be used as a source of supply to the bridge. And when the measurements are done at high frequencies, then electronic oscillators are used for the power supply. Now, electronic oscillators are used as the sources of supply because the frequencies provided by the electronic oscillator, they are fixed and they are not varying. Also, the output waveforms of the electronic oscillators, they are sinusoidal in nature, and the output power level of the electronic oscillators, they are suitable for the other bridge networks. So electronic oscillators, they are used as a source of supply because their frequencies is adjustable and their output waveforms is of sinusoidal nature and suitable for other bridge networks also. So if we talk about the sources of the AC bridge networks, then we can say that the power line can also be used and electronic oscillators can also be used as the source of supply. Now, if we talk about the detectors, now if we are working at a single frequency, if the frequency of the working frequency is constant, then it is more suitable that we are using a tuned detector. Okay, because tuned detector will give us the maximum sensitivity at that frequency, at that specified frequency, and also the disturbance due to the harmonic frequencies, that will be reduced. So in the case of detectors, we are talking about the tuned detectors. So three types of detectors are used in the alternating current bridges. These are headphones, vibrational galvanometers, and tunable amplifier circuits. Okay, there are different frequency ranges, and in that frequency range, a particular detector will be used. Like the headphones, they are used in the frequency range from 250 hertz. This is the lowest frequency range, and above upper level of the frequency range is above up to 3 to 4 hertz. So the lower working range is 250 hertz and the upper working range is 3 to 4 kilohertz. So in this range, headphones are used. Vibrational galvanometers. Vibrational galvanometers are used as detectors when the AC bridges, they are working at the power frequencies and the low audio frequencies. So frequency range will be from 5 hertz to 1000 hertz, and it is more sensitive below the 200 hertz. It means vibrational galvanometer, they are working at the power and the low audio frequencies. Okay. Another is the tunable amplifier circuits. The tunable amplifier circuits, they are used in the frequency range from 10 hertz to 100 kilohertz. Okay, so we can say that these three detectors, they are used according to the frequency at which we are operating the alternating current bridges. So here in this video, we studied about what is an alternating current bridge, how the circuit of the alternating AC bridges, they consist of that we are having four impedances Z1, Z2, Z3 and Z4. Also we have a detector which is checking the null condition, and we have an AC voltage source. Okay, and also we saw that what are the various types of sources and detectors which are used in the AC bridges or the alternating current bridges. So I hope that this topic, what is an alternating current bridge, is clear to you. Thank you.